deploy lottery, because we're going to want to work with the lottery. And now we're going to want to, that when people try to enter a lottery that hasn't started yet, it's going to revert. So we can use what we've used before. We'll say with pytest.raises exceptions.virtual machine error lottery.enter from get account value lottery.get entrance fee. Of course, we're going to have to import both get account from our helpful scripts and exceptions from Brownie. Perfect. And this as well is following the arrange. This is actually act/assert. So let's go ahead and test this. Brownie test-k. Test can't enter unless starter. Oops, let's do start ed. And great, that's passing as well. Let's go ahead and keep going down this list. What else? Now that we've tested whether or not they can't enter, let's test whether or not they can enter. So we'll do def test can start and enter lottery. So we're going to copy this again, paste it down here since we're going to work on a local blockchain. We'll do lottery equals deploy lottery. Account equals get account. We'll start the lottery, lottery.start lottery. We'll do from account. We'll do lottery.enter from account. Say value is lottery.get entrance fee. And then we'll assert that we've correctly added a player to this lottery. So we'll assert lottery.players of 0 is going to be this account, right? Because we have our players array, and we're going to assert that we're pushing them onto our array correctly. Lottery.players of 0 equals account. So here's our act, and here's our assert. So let's try this now. Brownie test-k, test can start and enter lottery. And once again, awesome. Things are looking great. Now, let's test to see if we can actually end a lottery. So we've tested we can start a lottery. So we'll do def test can end lottery. We're going to copy this again, paste it down here. We'll do lottery equals deploy lottery. Account equals get account. We'll start the lottery with lottery.start lottery. Now we could 100% just import the rest of these functions in here, like end lottery, enter lottery, and start lottery. And similar to how we're just doing lottery equals deploy lottery, we could absolutely do that. For being very verbose here, I'm just going to go ahead and write all the functions and transactions myself. And this way, we'll actually be able to test a little bit more granularly. Anyways, we'll do lottery.start lottery from account. Do lottery.enter from account. We'll give it a value. Lottery.get entrance fee. Oops, I'm going to have to do account, of course, equals get account. Now, to actually end the lottery, we do need to send this some link because we're calling request randomness. We use our fund with link script that we have in our helpful scripts. We'll import this from our helpful scripts. We'll call fund with link on our lottery contract. Once we fund with link, we'll then call lottery.end lottery from account. And then how do we actually know that this is being called correctly? Well, if we look back in our lottery contract here, when we call end lottery, we're not really doing a whole lot. All we're doing is changing our state. So let's go ahead and check to see if our calculating winner state is different. So we'll say assert lottery dot lottery state is equal to what? So calculating winner, if we scroll up to our enum, is in position 2. Open is 0, close is 1, calculating winner is 2. So we can say assert lottery.lottery state equals to 2. We can go ahead and test this as well. We'll do brownie test-k, test can end lottery. We'll see if this works. And it does. Now let's test the most interesting piece of this entire lottery contract. We're going to test whether or not our fulfill function actually works correctly. Does this correctly choose a winner? Does it correctly pay the winner? And does it correctly reset? So let's go ahead and build our most complicated and most important test of this whole contract, choosing the winner. We'll do def test can pick winner correctly. Let's copy paste this bit about getting started. We'll do lottery equals deploy lottery. Account equals get account. We'll do lottery.start lottery from account. And then we'll enter with a couple different players. We'll do lottery.enter. Well, let's say from account value lottery.get entrance fee. Lottery.enter. And we'll copy this 2 more times, but instead we use some different IDs. We'll do index equals 1, and we'll do index equals 2. These are going to be different accounts here because we're going to use a different index because we want to just test for multiple different people here. This unit test is getting drastically close to being an integration test, but as I said, we're being a little bit loose with the definitions here. Now we're going to want to fund it with link, so we can just go ahead and copy this line here. Fund with link lottery. And now we're going to want to choose a winner here. And this is where we actually have to modify one more thing in our lottery contract. So in order to test actually calling this fulfill randomness function and testing everything in here, we're going to need to call this fulfill randomness function. Now, if we look at our VRF coordinator mock, we have this function called callback with randomness. And this is the function that actually calls this raw fulfill randomness.selector, which eventually will call that fulfill randomness function. But this is the entry point that the node actually calls. We have to pretend to be a chain link node and call this function. We're going to return a random number, of course. We're going to choose the contract we want to return to, but we also have to pass the original request ID associated with the original call. Now in our lottery contract, our end lottery function isn't going to return anything. And even if it did, it would be really difficult for us to get that return type in our Python. So what we want to do to keep track of when this contract actually entered the calculating winner state is we want to do what's called emitting an event. Events are pieces of data executed in the blockchain and stored in the blockchain, but are not accessible by any smart contracts. You can kind of think of them as the print lines of a blockchain or the print statements of a blockchain. We can go to this logs section, which also includes all the different events. Now, there's a lot of information here, so we're actually going to do an event ourselves just so that we can see what this really looks like. You can see here that when we call this end lottery function, in the logs, if we scroll to the bottom, there's an event here called randomness request. This was spit out by the VRF coordinator. This was spit out by the VRF consumer base that we inherited. And it even has some data that's already been decoded. One of those pieces of data is the request ID. Now, to add an event, we first need to create our event type. So at the top, we'll go ahead and do event requested randomness. We'll say bytes 32 request ID. So now we've identified a new type of event called requested randomness. It's really similar to the enum in this regard. To omit one of these events, all we have to do in our end lottery bit is we'll do omit requested randomness and then request ID. Because requested randomness takes a bytes 32 as an input parameter, and we're going to pass it that request ID as an input parameter. Now that we have this event being omitted, back in our test, when we call end lottery, it will actually omit one of these events to our transaction. So what we can say then is transaction equals lottery.end lottery. Same way we've always done it. But now we can look inside of this transaction object. Inside of this transaction object, there's actually an attribute called events, which stores all of our events. We can then look for a certain event name, which we know is requested randomness. So we'll say, out of all the events, look for the requested randomness event. And in there, in that requested randomness event, find the request ID. Request ID. Now we can say request ID is going to get grabbed from this event that we emit. So these events are going to be really helpful for writing tests. These events are also really helpful for a number of other reasons. One of the big ones is upgrading our smart contracts or understanding when a mapping is updated. But for now, we're going to be using them for testing. Now that we have this request ID, what we can do is pretend to be the Chainlink node and use this callback with randomness function to dummy getting a random number back from the Chainlink node. So what we're going to do is we're going to call our get contract function and get that VRF coordinator. Of course, we're going to have to import it from our helpful scripts. And we're going to call that callback with randomness function. So we're going to do dot callback with randomness. And we need to pass it this request ID, a random number, and then the contract to return to. So we'll do request ID. We'll do some random number, like we'll say static RNG equals 777. So we'll say the random number that we're going to return is going to be 777. And then we'll do lottery.address because we're going to return it to the lottery. Once again, we're going to say from account because this is making a state change. And now that we've got a callback, what we can do is do our asserts now. So this is us dummying getting a response from a Chainlink node. And this is how we mock responses in our tests to make our lives way, way easier. So now we can figure out who the winner of this lottery actually is. If these are our three entries, that means it's 777 mod 3, since our random number is going to be 777. If we pull out a calculator, 777 divided by 3, it divides evenly. So we know that this means the answer to this is going to be 0, aka our account is going to be the winner. So let's assert the lottery dot recent winner is going to be equal to our account, right? Because we set a recent winner in here. We transfer them some money. We'll assert lottery.balance is now 0 because we're transferring this account all of the money. And let's even make sure that the account gets more money, right? So we'll do starting balance of our account. Starting balance of account equals account.balance, and we'll do balance of lottery equals lottery.balance. And then we'll assert account.balance is now going to be these two added together. Starting balance of account plus